Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Rocket Sound Suppression System. So let's dive right into it. Well, first we have to understand why the heck it's such a big deal. We are talking about launch sound here. Now you have to understand this. Energy is directly proportional to how high you are talking about. Basically, 1 watt is not an issue, 1 megawatt is an issue. So we are talking about something ludicrously high. It's a very high energy event. Now that in itself is not too much of a deal because again, thunder and all that, those also have high energy. But this puppy is a sustained event. That's the big problem. It's not that once you ignite the rocket, then there was a big boom and then you have to handle that. No, it's like continuous. It's like now that's the main issue because you have to understand there is a lot of energy conversion happening. Now where is that energy coming from? That energy is coming from your propellant. Basically you have a lot of stored chemical energy. You're converting them into actual mechanical energy. Now that conversion efficiency is not 100%, so a lot of energy is wasted as heat and sonic energy. Basically sonic would be stretching it, but you get the point. Basically there is a lot of sound wave going on. And why is that happening? Because ludicrously hot, super high speed exhaust gas is mixing with atmosphere, and that's not a very smooth process. So it's creating a lot of turbulence in the atmosphere, which is causing a lot of basically acoustic energy. Now the reason we call it acoustic energy, not just loud sound, is simply because of the levels. Now we utilize in sound industry decibel scale. Now problem with that, we humans cannot understand it. It's literally like saying 10, 100, a million, a billion. It's like that. It's ludicrously, it goes logarithmically high, so it's kind of difficult to absorb. So when somebody says 100 decibel, you know for a fact that's loud. And when somebody is talking about 120 and 130, you're like, yeah, that will hurt you, that could basically render you deaf. But here's the once you start to cross 150, 160, you are talking about physical damage. Basically it will physically move objects, not only person but a whole building. Once you are talking about 180, 190, yeah, that's a like a demolition charges level. Now Saturn V at its peak reached above 200 decibel. Now to give you a context of that, that sound energy, basically acoustic energy, is so ludicrously high that it will set grass on fire without heat. Basically that how much energy we are talking about. Basically if a person was trapped inside that zone, it will not be a human body. Basically it will be something used to be there, something that turned into chunky salsa. So there's a lot of acoustic energy here, and the bigger the rocket engine, the more energetic we are talking about here. So the sound level is on a different level. We humans are not, again, we are not stupid enough to put humans next to it, so we know for a fact that it is ludicrously dangerous. So but common public is not aware of the basically the oomph that these sounds have. So what kind of damage we are talking about? I specified this is not only a big energy event, it's a sustained event. So it's not like until a rocket goes to like quite a high distance, basically let's say 500 meters or something like that. At that point it's like, yeah, sound is naturally dissipating enough that it will not destroy anything. But you can understand that will take few seconds. You are basically, that's a going big boom event happening for few seconds. Almost every structure will be destroyed at that kind of high intensity. So you have to, that's why we do not call it sound. It's basically pressure wave. It's at that point, sonic boom if you want to think. So physically destroying things, it's not only limited to concrete structure, it can literally shake apart basically metal pipes. And the another side effect of that, because of how shockwave has been generated in this rocket scenario, it creates a very low frequency oomph, so to say. Side effect of that, that low frequency is very close to resonant frequency of almost everything. So physical things will start to vibrate at that rate, because if it was too high frequency it will just go through, but if it's low enough it can impart energy into that. That's like a big no-no. That at that point it's like, nope, your structure is gonna go nope if that happens. So not only that, it is gonna damage the launching pad and surrounding structures, it can also bounce back from land and destroy the rocket also. So it's not like, oh, I'm launching a rocket. No, you have to figure these things out. That's a very big issue that people had to figure out using ICBMs. They were launching it and boom, the rocket destroyed itself. So you have to understand this is something very serious, very thoroughly thought of. This is something like, we don't think too much about it, but whoever job it is to launch a rocket is like, dude, this is my nightmare, so to say. So the damage we are talking about is not minor, it's very serious. So how do we handle it? Well, first, dig a ditch. The reason for that is basically sound waves have this ability that they can be guided. You cannot you basically fight the sound wave, nor you can absorb it. The intensity here is basically, if you put a sound absorbing foam there, it will turn to dust. The amount of energy is so high, so you cannot absorb it. However, you can guide it. Now ideally you want to take the sound and you guide it 90-degree away. Basically no matter what happens, you do not want it to bounce back. If it bounce back, your say bye bye to your payload or person if there is people on board. So first thing, you take it and you bend it 90 degree. No matter what happens, it must be perpendicular to the launch system. that is necessary. So we utilize flame trenches because again the sound is coming mainly from that rocket exhaust. So guiding it away while you are also guiding the sound. So it's like a double duty kind of scenario. Now many times people see like a presentation where they're like, okay, Americans use like flame trench and water, and Russians just have a giant trench, they do not need to waste water. That's true to partial extent, but you have to understand this trench, it's a small part of a building. This trench is big enough that you can literally basically sink the whole rocket. Because of the location and the basically ludicrously low temperature, they had to do this. They could not rely on water, and not to mention this is a small rocket. So when the Russian would be wrong thing, Soviet Union were working on lunar rocket, basically their Saturn V, they had water suppression system built into mind, because you have to, once you start to use really big rockets, no amount of ditch can handle that, and this ditch is ludicrously hard to imagine. Basically, I would urge you to Google this, basically how big this ditch is. It's like it's a freaking huge structure. Not to mention like the amount of money you will save in the water, you will lose more of that just in concrete. So this flame guiding, it's a good thing. It's a first step, right? That's the first thing you start, and then you build on top of it. But do not think like, oh, this is one thing that you can deal with that. It's good for small rockets, but even in electron rocket, you will see people using water. There is a good reason for that. This is like a very tough solution. They had to do it, so they did it. But ideally, you do not want to utilize this because you will waste up too much land, and not to mention you can notice like there are not too many things around there. While in NASA's case, all launch pads are like populated with a lot of things, so they do not have the luxury just waste a large amount of area. So ditch, it's a good step, it's a first step, it allows you to have a fighting chance. Then we utilize the Brahmastra, so to say, water. Now, water, basically, the moment you spray it there, it will become what we call droplets. Now, water droplets, because of their mass and other properties, they will hang in atmosphere for a few seconds, or sometimes even few milliseconds, but that's more than enough to absorb energy. So what happens that the moment a shockwave, very high energy shockwave hits water droplet, it literally acts as a converter. It takes ludicrously high energy, gets heated up again. Energy cannot be created nor destroyed. So what happens to water droplet? It heats up. What happens then? It goes from high heat to steam. Basically, you cause a phase change. So that's why whenever you see rocket launch, you see huge steam plume. Where the heck that steam is coming from? Especially if you are using basically kerosene as a propellant. Where the heck that steam is coming from? Launch pad. So this giant amount of water literally turns to steam. So not only it's cooling the area down, not only it's acting as a fire suppressant also, because again this is giant flame tower that's going there. So it has dual purpose there, and this is the only way we can absorb basically reflection. Basically, no matter how powerful your rocket is, like SLS was a very big deal because they had 5-stage boosters on that. On top of that, they're gonna have 4 RS-25 engines. Those are big puppies. So there was a very serious the sound. If it bounced back, even with a trench structure, it could bounce back and destroy the rocket. So they had to make sure the water is sufficient enough, and that's the same issue happened all with space shuttle also. That's why you will see a lot of packets, so to say, was strung along in the launch side to absorb that extra bounce back sound. So it does that. Basically, water droplets acts as a perfect barrier. Basically, it takes something like 190 decibel, tones it down to gentle 140 and 160 decibel. Again, it's still a person destroying, but not building destroying. And definitely, basically, the way it's designed, the way the guiding system works, no matter what happens, it does not bounce back to rocket. So rocket will not be destroyed, and your structure will survive it. So water is the main tool here, and we simply use as much as we need it. It's like you do not think about liters here, you talk about in hundreds and millions of gallons. So it's not something a small task, but you have to understand this is the only way we know how to absorb a ludicrous amount of energy without turning digging a ditch that is like few kilometer deep. So that's why we use water. That's why everywhere you see water supply, even in electron rocket. That is why, like, it's tiny droplets, they are surprisingly good at converting acoustic energy into steam. And not to mention, because it's steam, it's no longer like you converted flame energy into flame energy. So what about rockets? Again, we talked about pad and all that, and pad has taken care of, let's say, reflections and all that, but again, you still have the engine attached to your ass. So it's very serious. Now, payload is the main money-making stuff. So protecting the payload is the first priority. So generally, you can see fairings, and generally they have a lot of sound absorption built into it. And in basically Falcon 9, you can easily see those sound absorption tile. However, you have to understand that SpaceX figured it out that it would be much cheaper to make the satellite much more robust against sound wave than to add sound insulation. Benefit of that, I think they managed to cram one extra layer of satellite just by removing the payload weight of the, basically this is also payload. Every time you tone down weight from basically fairing, you save money. So They did that, and many times rockets like India's PSLV, they need sound insulation at least in the beginning stages. Once you start to go up and once you start to gain velocity, sound is no longer an issue, and once you are at high up, it does not matter because again sound will not come bounce back. So sound insulation is used in rocket. It's a like absolute engineering thing. Like you may think about fairings, you're like okay, structure, vibrations and all that, but you have to think about sound also, because again it could act as a resonant cavity, and bye bye your payload. So this is also a very serious thing. So sometimes depending on what kind of fuel you're using, what kind of a gimbal system you have, rocket could need extra protection, or sometimes like most of the time you need giant protection for your payload. So this was my presentation on basically rocket launch sound suppression system. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I like to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.